This is problem 3 from the 2010 midterm. So we've taken a simple random sample of 126 male college students and 324 college female students. The male students average 3.89 alcoholic drinks per week. Alright, that's important. With an SD of 5.9. Remember, this is sample SD. So the female college students average 1.97 alcoholic drinks per week with an SD of 3.1. Now they say 55% of college students are female and 45% male, and we know that 20% of men and 40% of females just don't drink at all. So this will be, that second part will be pertinent later in the problem. This part, the numbers I underline now, will be relevant to Part A, because we're asked, do I think men and women differ in the amount of alcohol consumed per week? Perform an appropriate statistical test if necessary. That's exam code for perform an appropriate statistical test. So what do we do here? We have a null hypothesis, right? Null hypothesis, men drink equals women drink. Women drink. And the alternative is, what are we asked? So, do they differ? That's a key word. Do they differ? Does that mean we do a one or a two-sided test? It means we do a two-sided test because we're asked if they're differing. We're not asking which one's greater. We don't care which one's greater. We only care if they differ. So, let's call it M is not equal to W, right? The men and women do not drink the same amount. That is our alternative hypothesis. So how do we test this hypothesis? Well, remember we have this formula. We have the observed minus expected over the SE of the difference. Difference of what? The difference of the averages. So what is the SE? So we have to compute the SE for men. So the SE man, SE for the men, the sum, remember this is the average, the SE for the average of the men is 5.9, 5.9 divided by square root of 126, and that is approximately 5.26, 0.526, and the SE for women is the sample SD, so that's 3.1, divided by square root of how many of them we sampled, which is 324. So that's equal to 0.172. So then what's the SE for the difference? And that is equal to the square root of SE men squared plus SE women squared, right? So that we can plug in this number here, we can plug in this number here, and that we get 0.553. So now we go back to this equation up here, observed minus expected over the SE of the difference. Well, the expected difference is 0 because that's the null hypothesis. They drink the same amount, so if they drink the same amount, we expect a difference of 0. The observed difference is 3.89 minus 1.97 divided by 0.553, so that's equal to 1.92 over 0.553. Now we can do some calculations, but what's really important is this, I don't know exactly what it is, I didn't do the calculations, you just plug it into a calculator, but the point is this is bigger than 3. This is bigger than 3, obviously bigger than 3. So what does that mean? Well, the p-value is very low. So right, p-value, this means that the p-value that the p-value is less than 0.3. Why? Because of our empirical rule. If this is a normal curve right here, this is 0. I think my normal curves are improving. Just as I said that, I made it went down too far. That's okay. This is our normal curve. And if we're testing for greater than 3 or greater than whatever this is, let me just get a calculator out. It's 1.92 divided by 0.553. See, look, I'm doing it. Calculator. That's equal to 3.47. That's 3. So it's 3.47. And remember, it's a two-sided test. So this is 3.47. Look at this area. And also negative 3.47. Why? Because what's the question we're asking? What's the probability of seeing a result at least this extreme? So at least this extreme means at least 3.47 SDs from the mean, from the mean, which is 0 in this case. And we observe, and that probability is very, very small. P-value is 0.03, sorry, this is a percent. So that's 0.003. Why? Our empirical rule says that 99.7% of the area is within 3 SDs. So it's very, very small, and that means we reject the null.